Hi, in this video I'd like to go over another parallelogram law example, and in this example I'm going to take force F1, a force F2, and figure out what their resultants are, and figure out what this resultant angle is from the y-axis. So to briefly go over what the parallelogram law is, I've drawn this parallelogram. And it says that it doesn't matter if I have two vectors, if I go A plus B, or if I go B plus A, I'm going to get the same resultant vector. And that's shown here. R is equal to the vector A plus the vector B, or it's equal to the vector B plus the vector A. And we're going to also leverage some other identities of a parallelogram, mainly that opposite angles are equal to each other when we're dealing with our force vectors. So here's my force vector F2. I had started to draw this to try to save some time. And here's my force vector F1. And the first thing I'm going to do is draw in this, make these force vectors look like a parallelogram. So I'm going to draw in this force vector F1. And I'm going to draw in F2. And what you can see is that these vectors are equal to each other, except they're just at a different point. They're just translated. So it doesn't matter if I do F1 plus F2 plus F1 or F1 plus F2. I go to the same point, and I can figure out what my resultant is. And we'll call that R. Now I need to figure out what these angles of these parallelograms are. And the way I can figure out this angle and it is by figuring out what this angle F1 makes with the vertical axis is, and figuring out what this angle F2 makes from the vertical axis. This angle down here is very easy. It was given to us. It's 30 degrees. This angle up here is also given to us, but it's given to us in a different way. It says that this line has a slope of a 13 or a 5, 12, 13 triangle. And to figure out what the theta is, theta, we're going to use the fact that this is given to us. It's a right triangle. We can use SOHCAHTOA. I like using tangent. So we can figure out that the inverse tangent of opposite, which is 5, over adjacent, which is 12, is going to be equal to 22.6. So this angle right here is 22.6. This angle down here is 130. We know that, I'm going to draw this and then erase it, this entire angle right here is 180 degrees. I'm going to erase that just because it gets a little messy. So if we have 180 and we take away this bit of the angle, so we subtract 30, and then we take away this bit of the angle, so we subtract 22.6, we're going to be left with 127.4 degrees. And this 127.4 is what this angle is right here. So this is 127.4. Now because it's a parallelogram, we know that opposite angle is the same, so that's also 127.4. And we need to figure out what this angle is. And if we figure out what that angle is, we can figure out this angle right here. Now, a parallelogram, all the interior angles are equal to 360 degrees. We know that these two angles are the same, so we really only have one unknown. What is this angle? So if we have 360 degrees, we subtract this 127.4. Now we're going to subtract this 127.4. And this answer right here is going to give us this angle plus this angle. Since these two angles are the same, we're going to divide it by 2. And let's just give this a name of this angle. Let's call it gamma. So we're going to have gamma is equal to this total angle 360 minus 127.4 minus 127.4 divided by 2. And this is going to give us an angle of 52.6 degrees. So this right here is 52.6. Now I'm going to draw just the upper part of this triangle so it's a little easier to see. So we have F1, F1. We're going to have F2. And F2 is equal to 26 kilonewtons. I should write right in what F1 is. It's 30 kilonewtons. And F6, that's my hotkey. R is going to be what we're looking for. Now, we don't know exactly what this angle is, so alpha is unknown. We don't know what this angle is, so beta is unknown, but we do know what this angle is. So gamma is 52.6. If we look at everything that we have and what we don't have, we notice that we can find R if we use the law of cosines. So the law of cosines says that C, the angle C, the law of cosines says that this side length of R, so R, is equal to the square root of F1 squared plus F2 squared minus 2 times F1 times F2 times the cosine of 52.6. And the square root is over this whole thing. If we put it in our numbers, we know that this is the square root of 30 squared plus 26 squared minus 2 times 30 times 26 times the cosine of 52.6. And we get a length of 25.1 kilonewtons. So this is the length of the resultant. Now, in order to find what this angle the resultant makes from, let's say, the positive y-axis, from the positive y-axis, we know it starts here, and we need to figure out this entire angle. So we need to figure out what alpha is, and we can figure out what alpha is by using the law of sines. And the law of sines says that the sine of alpha over A, so this is a side length A, is equal to B over the sine of beta is equal to C over the sine of gamma. And you can pick any of these two lengths normally with the law of sines. For us in this problem, this is going to be equal to this because these are, if I call this side C, I have my gamma. Side A, I have my alpha. So I have 30 over sine of alpha is equal to this resultant, which is 25.1. So 25.1 over the sine of 52.6. If I solve and isolate alpha, I get alpha is equal to the inverse sine of, what is this, 30 times, let's put it in parentheses, 30 times 52.6 times the sine of 52.6 divided by 25.1. And then alpha is going to be equal to 71.7 degrees. Now, this is not the angle that the resultant makes with the positive y-axis. This angle is just, let's get a different color. Yeah, it's just this angle right in here. So we need to add, for the angle from the y-axis, we need to add this 71.7 degrees plus this 22.6 degrees. And this gives us a angle of 94.3 degrees from the positive y-axis. So our final answer for this problem is the resultant is 25.1 kilonewtons at 94.3 degrees from the positive y-axis.